Good morning, everybody. Hope you're doing great. Good to see you. About 3 minutes, and then we will get our meeting going. So for now, anyway, thanks for being here, and hope you had a great weekend. And just get comfortable, and we'll be ready to go in a few. Hey, Rachel. How's it going? Hi, Valeria. Nathaniel. Always good to see everybody. Hi, Jamie. Hey there, Ruby. Cool. 1 second. Just gonna turn on one of these fans here. Okay. About 2 minutes, and then we will get our meeting underway. Hi, Leo, and hi, John Red. Good to see everyone. Hey, Marissa. Hi, Samir. Just another minute, pretty much. Hey, Ella. Okay, it is basically 11:30, so I'm going to let us get started. Welcome back, everyone. As I was saying, great to see you guys, and I hope everything's going well in your semester and your lives and everything else. But yes, let's just touch base on a couple of quick points. Have some of you guys managed to notice that I sent the fourth homework assignment? I distributed that. Have any of you guys noticed this? If so, just let me know. It's my first question for us. Good, Lily. Okay, perfect. Yes. So I've sent it to everybody. If you haven't yet had a chance to go look at it, please do so. Over the weekend, I mailed to the whole class through Titanium the fourth homework assignment, and I listed the due date there. I'm just now pulling up my own syllabus, and yes, you'll see that the due date is listed for Wednesday, December the 2nd. Yeah, is that correct? That's what we have, right? In the official announcement, it matches to the syllabus. The 2nd of December. Let me know, because I was just not sure if I adjusted that due date, but I think I kept it the same. Anybody looking at it? If not, I can quickly pull it up on my end and just double check. So let me just do that. Okay, I'm just going to our class, and yeah, oh, no, we did change it. Okay, thank you. I was just making sure because I thought that I made an adjustment. So yeah, please note that the due date, which is listed in the assignment, is the 7th rather than Wednesday of the 2nd. So I just moved it ahead to the following week after that one weekend, so you have another 5 days longer than what the syllabus indicated. So just making sure that's clear to everybody. There is a discrepancy. The syllabus says it's due Wednesday the 2nd. The assignment says that it's due Monday the 7th, but I've decided to go with the later date. So just know that it's due on Monday, the 7th of December. And so you've got still a good amount of time to work on it. Today's the 16th. So what is that? 7 plus 14. You have 3 weeks from today to still complete those 10 homework problems. And they're all derivations. I wanted to go over some information relevant to 2 of the problems, because 2 of the problems on the homework sheet are what are called theorems. I mentioned this in another message that I sent when I delivered the answer key for homework 3 over the weekend. So sometimes it's possible to conduct a proof without even being given any initial assumptions. And when you do that, when you make a proof of a proposition and it's got no premises supplied at all, that's what's called a theorem. In homework 4, there are 2 theorems in problem 7 and 8. So I kind of want to go through some practice problems on theorems so that you have a sense of how to complete those 2 questions. And then I'm just going to go over some more practice problems, and we'll just continue in that same way for the rest of the meeting and for the next couple of meetings. So here we go. I'm putting into our chat the link for a Zoom meeting so that I can show you guys on the board some common problems, well, in the screen share. So here we go. You see the link, so go ahead, click that, and I'll meet you guys over there. I'm going to, as usual, leave this stream running, and it'll be here archived for later use, but I'm now switching to Zoom, and so let's do that. Okay, and let's see. Okay, there's the chat. Let me actually, share the screen. Oh no. All right, so can we hear me, see me, everything? Let me type in the Zoom chat real quick so we're all clear. Okay, perfect. Thanks again, guys. So now what I'm going to do is just pull up some sections from the textbook. And here, first of all, is the homework, right? So looking at the homework problems, which that's what this is, you'll notice that most of them are stated in the same way that we're used to. You have a proposition you need to derive, some set of initial premises, and then you have to just make inferences using the derivation rules until you get to the derived result. But when you look at problems 7 and 8, I understand you could see that and be like, huh, because there are no assumptions given. But that's not a typo. These 2 problems are called theorems. So let's quickly look at the book, and I'm going to help you guys understand how to do some of these theorems. So on page 210, there's a little section. It's section 5.3, part 3. So practice some of these, and then that'll give you a better understanding and sense of how to complete the theorem problems on the homework. So let's go ahead and let's just try, for example, question C. You see that one right there, C? Okay, I'm going to zoom in a little bit so that's even easier to view. All right, so here's what you're being told to do in problem C, 5.33, problem C. Derive this conditional, which says that if A, then if B, then both A and B. So here's the goal. It is A, arrow, parentheses, B, arrow, A and B. Actually, here, B, yeah, so I'm going to use the angled brace just because they do. You have to derive this. That's problem C. Okay, so when you have a theorem, you don't have any assumptions. You basically have to start on the first line with your first move being an assumption. So let's ask, what kind of sentence is this? What is the main connective? What kind of sentence is that? Is it a negation? Is it a conjunction? Is it a disjunction? Is it a conditional? Is it a biconditional? What kind of sentence is this? Okay, good, Frida, it's a conditional. And the main connective is which of the 2 arrows? It is the first arrow. Okay, good. So we need to prove this big if-then statement, okay? We need to prove that if A, then all of that. Now, whenever you need to try and derive a conditional statement, right? When you're trying to get an if-then statement and you're trying to establish that in a derivation, in a proof, what's the typical rule that is used to create a conditional? It's called what? The rule which allows us to create a conditional, otherwise known as, just name of the rule. There's two rules, one for each, two for each connective. Sorry, okay, so conditional introduction. Great. Conditional introduction. So what is the antecedent of this whole conditional? What's the antecedent part of the conditional written here on the board? It's the first A. All right, good. So to try and derive this statement, let us assume this antecedent, and then we will proceed to try and get the consequent. So first move here, assume A, and that is for conditional introduction. All right. So now we've got it started. Now what is our goal? Since we have assumed A, we must somehow establish the consequent of the conditional within the proof. Now, what kind of sentence is the consequent? The consequent has complexity. It's not just a letter. It's not just a single atomic sentence letter, but it's a molecular formula with a bunch of different symbols and letters. So now just if we detach or remove A and the arrow here, and this is our consequent, new question, what kind of sentence is this? What kind of sentence is the information that starts with B and follows all the way through to the end? The main connective of the sub-clause of the consequent is what? Again, it's a conditional. Okay, good. So if we now need to establish this conditional inside of this larger assumption of A, then we're going to have to introduce a conditional again. So tell me if you think what can be the move. Okay, Tanya, you're saying B. Let's just be a little more precise. What next inference should I make on step 2? You're right on the right track. But let's just say it a little more formally. On line 2, name of the rule and what is the inference itself? Assume B for conditional introduction. That's right. Okay, perfect, good. So here is B now. Notice that it's another indented line over, because with each new assumption, we have to create another scope line. So we're assuming B, and that is for conditional introduction. Now look, what's the new goal? What is the goal just looking at this little subderivation? The one that starts with B will only close when we get to what part? Remember the rule of conditional introduction and how it functions. You assume the antecedent, and then you have to proceed to get to what? The consequent. So we need to find this conjunction inside the scope of the subderivation here. If you think you know what to do next, go ahead then and tell me. What should be the next step? On line 3. Keep in mind that we're not just flying blind here. Within this subderivation, this specifically is our goal. The consequent of the nested conditional. So tell me then what you think could be done to make progress towards this within this subderivation. Okay, Lily, one step at a time. I know you're thinking get to A and B, but we have to do it one step at a time, so let me know which one you want to take off. Well, yeah, actually there's another problem too with what you're writing there, Lily, because we can't do oh wait, yeah, you're right. I'm mistaken. Thanks, Lily. I'm totally off because I was, yeah, misinterpreting what you wrote. Very good. A and B. These two things can be conjoined, right, by conjunction introduction. Line 1 and 2, they say A and B. These are both still available because the subderivation of both has not yet been closed. So very good. Sorry for that for a moment. Anyway, A and B. This is from conjunction introduction, line 1 and line 2. Okay, so actually I maybe drew this line one too long. What is the result on line 4 then? What's the result on line 4? Well, I mean, look. Sorry, Lily, what do you say? Remember, line 2 does conditional introduction with letter B. From there, we use conjunction introduction to combine these two and form A and B. But once we've gotten to A and B, that was the whole goal of the subderivation here. So let me know on line 4 how to close that subderivation. It is not going to just say B. Okay, good. Yes, it says B, then A and B. The rule here is conditional introduction 2 through 3. All right? So let us be all clear about this part. We start with the assumption of A, and then the goal is find this conditional. But because this is a conditional, you have to use another application of conditional introduction. See, it's a conditional within a conditional. This is inside of this larger conditional structure. So 2 subsequent conditional introduction assumptions. First for the A antecedent, then for the B antecedent. Now, if we just zoom into this subderivation, it begins with B, and it has the goal to establish A and B as the consequent. Look up above, and you see that A and B are already available on line 1 and 2. So they can merely be then conjoined into this conjunction, A and B. From B, we obtain the consequent here. Once you get the consequent that you want, that closes the conditional introduction subderivation and gives us B, then A and B. But we have one more step, okay? What about the 5th step? What is the 5th step? Someone let me know. Because we've reached the end pretty much, but you have to tell me what information to provide on line 5. Look at the beginning of the proof and look at what is written on line 4. Okay? Using those pieces of information and your knowledge of how conditional introduction works, you should be able to tell me now what is written when I close the subderivation that started with A. Just let me know what to write on line 5 to close the subderivation that began with A on line 1. Only you know the answer. You have to tell me. That's the way it has to be. So please, just let me know what is the answer on line 5. Okay, good, Amayan. It's the formula that you want to derive. It's just this. It's that whole thing. And it is based on, but it's what introduction? It's conditional introduction. Tanya, you're close. You gave the right rule, but the wrong numbers now. What's the numbers to cite? It's 1 through 4. Okay, well, yes, very good. 1 through 4. Perfect. A, then B, then A and B. And that is conditional introduction 1 through 4. That's a proof involving a theorem here. Okay, so derive this conditional. No assumptions. So you initiate the assumptions. Assume A, and then this will be your goal. Since this is your goal, now you just focus on this as though that's the whole proof. Since this is a conditional, it requires the assumption of the antecedent, which is B. And then we just move on to trying to establish this part. Easy enough, because A and B lie on line 1 and 2. They can be conjoined using conjunction introduction. So that means we can close this one because B has been introduced as an assumption, leading us to the consequent. Therefore, we close it and we get B arrow A and B. But now look, B arrow A and B, all of that stuff is contained in the subderivation that began with A. And that is why we are then able to close this one and provide the entire sentence where A is the antecedent and this whole thing is the consequent enclosed in brackets. Okay, good. And not to worry, Amaya, just trying to make sure everyone's got the right information for this problem. Okay, so that's one of the theorems. Let's try another one just to kind of, make sure that we're all understanding it pretty well. And as I'm looking here, Okay, just making sure I'm not doing one that is identical to the homework problem itself. Okay, so let's do the next one. Let us try, I'm looking at K, A, B, A, then B. Okay, let's try problem K then. And this is also still in part 3. 5.3 part 3, letter K. All right, so you see it there displayed on the screen. It says simply to derive that if A, then if B, then if A, then B. Okay, so let's see what's going on here. Now, maybe since I've walked you through one example of a theorem, you can get this one started without me guiding you so much, but I will if necessary. So what do you think should be the first move in this new theorem proof? No assumptions given? Good, Amaya. Let's assume A. Why has this been done? Okay, let's all understand. We're not doing this arbitrarily or just randomly. We're assuming A specifically because it is the antecedent of the conditional. And so that's how you have to go forward when you have a conditional that you're told to derive. So we're assuming A. And that is the assumption being made for conditional introduction. Okay? So we started, we're moving forward on the proof, but that's of course not the end. We've got one step under our belt. Good, Tanya. So you say now, B is the second line, and that's also assuming for arrow introduction, for conditional introduction. Sorry, let me make sure to indent, as you always have to do when you make a secondary assumption. So that is assumed, again, for conditional introduction. All right. We've assumed A, we've assumed B. Within the scope of B, we want to find this consequent. But wait a minute, this consequent is a third conditional. So what's to be assumed on line 3? Maybe I'm giving away too much. What is the step you would take on line 3? Just let me know. Okay, you say A, then B for conditional introduction 1 and 2. We're inside of this subderivation, as if this is the only part of the proof that exists currently. And we're simply trying to get this thing proved. A arrow B somehow in here. But A arrow B is a conditional sentence, which means that you actually have to build another conditional. So that's a big hint. What do you think then? Line 3. Let's see. We're not quite there yet, Amaya, but we will get to that statement in just a step or two. But first of all, what do you think, guys? We're working on getting this part of the sentence placed within this subderivation. The final consequent of the big complex conditional here has a main connective in it. You have to then build a statement with that main connective, which uses those letters. So what is the third step of the proof? Okay, do I need to say this explicitly? You can have a billion, million subderivations. It's not limited to 2. I mean, billion would be probably too many, but in theory, any finite number of subderivations could be found in a given proof. So you took 2 correct steps. What's up with this third one, guys? Are you getting lost? Tell me about the third step, please. What's the next inference? Good. Assume A again. And no, Tanya, you can't just, there's no conditional elimination that is possible, Tanya, because there's no conditional here. There's letters, A and B. But you can't do conditional elimination unless there is a conditional there. Okay, so, but Jessica, good. Assume A again. That's right. And the rule, please, is what? Gotta say the rule too. But yes, you're assuming A again. Based on what rule though? Conditional introduction. Correct. Okay, so look. Now we are in a sub derivation here. But let's just focus only on this one, this third one. What are we trying to prove here? If A, then B. So now we can start working backwards from that final consequence. So tell me then, what shall I do on step 4? And when I do it, then I can start to close the subderivation on step 5. But do let me know. Step 4. Think about it, take a moment, but you know it. You know what to say. Line 4. There's a clear thing you're trying to do here. You're trying to prove that if A, then B. Okay? You assumed A. So, conditional introduction. Conditional introduction. How does it work? You assume the antecedent. Then you got to establish whatever the consequent is. So, Frida, no, not yet, because you can't close this subderivation without having any consequent or anything in there. Okay, so you're right that we want to get to A then B, A arrow B. No, it's not assuming B again. It's reiteration of B. B is already there, it doesn't need to be assumed, it was already assumed. It's been assumed, that's what we did on line 2. So now we can simply reiterate it. Reiteration, okay, very good. B, reiteration from line 2. Okay, so then line 5, the next step. This was the goal, A, and then we found B. So if you remember how conditional introduction works, then you should definitely be able to tell me what is the answer on line 5. Well, not the answer of the whole problem, but the next consecutive step. We have a subderivation where we assumed A, then B fell underneath that. Keep the goals in mind. The goal of this was simply to have B, so we got the goal. Okay, good, Tanya. Now we are able to write A arrow B. That's true. And the rule is correctly cited. That is based on conditional introduction, line 3 through 4. Okay, so we assumed A again. B was reiterated from line 2, and that closes this subderivation, so now we have A then B. But look, A arrow B is now below this letter B, which we assumed for conditional introduction in the goal of building that big conditional. So now on line 6, just tell me what's that result. Okay, good, Tanya. It's B arrow A arrow B. Conditional introduction 2 through 5. All right, and there is one more step to go. If you keep your eyes on the prize, this big thing, we still don't see this sentence written in the proof, and it's never done until that derived result occurs in the proof. But good, Tanya, now we will simply have the full formula. You don't have brackets around both sets of the leftmost B, but that's fine. Okay, so A arrow, angled bracket, B arrow, curled parenthesis, A arrow B. And that is conditional introduction 1 through 6. 1 through, get the number there, Tanya. It's 1 through 6, just because 6 is the last number that occurs before 7 right here. So anyway, there you go. That's the proof of this particular theorem in 7 steps. So the basic pattern that you're seeing is, if you're told to derive a big conditional, and you have no assumptions that are given to you, then you would start by doing conditional introduction assumptions for as many antecedents as exist within the proof. Now in this case, there are 3 different antecedents because there are 3 nested conditionals. There's the antecedent B related to, sorry, the consequent B related to the antecedent A, the consequent A then B related to this antecedent B, and the big consequent of this conditional with A as its antecedent. And that's how that proof would go. Now, just so that we can see how this relates to the homework, I'm not going to necessarily solve the problem, but while we're all here together, let's get a sense of how maybe we'll get started, all right? So let me just ask any of you guys, which one would you prefer if I'm going to have some in-class discussion? Which one, 7 or 8? Any of you on that? I'd defer to you. You're saying 8? All right, fair enough. So let's take a quick look then at 8. Okay, so here's what it says to derive. Derive that if both A and not B, then in that case, if not C, then not B. So what would be your guess here as how to start this one? I'm not going to say anything. You have to say everything. What would be your guess about how to start this one? Yes, but we've got to be more specific. I mean, let's be detailed. We just went through a couple practice problems. No, not correct. Maya, that's not correct. I'm just not going to say anything until you get the correct information. Then I'll help you a little bit. Think. No, Nathaniel, no. Not true, not correct. Both of these things you guys are trying to do are like, I mean, sort of along the right lines, but you're not assuming the right thing. Okay, good, Lily, that's better. Look at what Lily wrote, everyone. Can we understand that? Why did she write that? Why did she just write not just A, or not just, it's confusing anyway. It's because it's the antecedent of the conditional. When you have the antecedent of the conditional, you assume the whole antecedent, not just one letter in it, or in the case of B, something that's not even found in it. You have to assume the whole antecedent. And that antecedent, you can see it, it says A and not B. Sorry, what's the rule? It's the rule of conditional introduction. Okay, now, if we were going to continue going through this proof question, what would be the thing that you are now trying to get inside this subderivation? You've assumed A and not B. You're thinking, or you're hoping that you'll then get to what? From that. Ultimately, what statement needs to be placed inside this subderivation so that you can close the whole proof up and finish it? The proof will be done when you arrive at what information on a numbered line? Well, yes, good. The consequent, which says tilde C, then tilde B. So now the goal within this subderivation would be to find this conditional, okay? So you would then proceed to make whatever assumptions and inferences that you would need to make to place this conditional within the subderivation that you're going to establish. When that is closed, then you can close the whole conditional introduction assumption, and then you'd have your proof, okay? That's all I'm going to say about it, but that should be enough for you to get the answer. Let's take a look at number 7. Okay, so number 7, let me write the whole thing out. It says if A, then, so if A, then if B, then C. Then in that case, You know what? I need a little more room, so let me just start back over here. Okay. If A, then if B, then C, then if both A and B, then C. Okay, so let's just examine this statement. What is the main connective of this statement? What kind of statement is it, and what is the main connective of the statement? The thing to derive is known as a blank. What kind of sentence is this? Yes, that's the symbol. Tell me the word, please. It is a conditional. Okay, now which of these arrows is the main connective of the conditional? It is the third one from the left. That's right. So it's this one. Because this arrow is the one that connects this entire big complex antecedent with this entire complex consequent. This is not the main connective because this only connects these two parts that are within the brackets. This is not the main connective because this is contained within parentheses, and same with this. But this is the one that it occurs outside of all of the bracketing and parentheses. Okay? So Jamie, when you say outside one, I'm not quite sure what you did mean. But I guess if you mean outside of parentheses, yes, this is outside of parentheses. But the word outside can sometimes be ambiguous unless you supplement it with outside parentheses, because sometimes people say outermost, and they just mean the one that's the farthest to the left. But anyway, yeah, this is the one. Okay, so that's the main connective. So it's a conditional. So that means that you would have to start a proof of this proposition by doing what? Now you just tell me how you would begin this proof. Okay, Tanya, good. So you say to assume that if A, then if B, then C. And we've assumed this for conditional introduction, right? Now, that's getting the proof started, because what we have to assume is the whole antecedent, which in this case is all of this information here. Now, having assumed this antecedent, we must prove the consequent. What kind of sentence is the consequent? Well, it's another conditional. So as we've been doing a few theorems so far in the meeting today, you should already have a kind of at least somewhat partial understanding of how this part of the proposition is then going to be established. You have to make another assumption after this initial assumption. The second assumption will take as its goal the establishment of this conditional over here. Okay, and then there would just take a few additional steps. Well, so Tanya, not correct exactly, sort of, but not. You have one thing there that's wrong. Maybe someone can tell Tanya and me and everyone. What would be the correction for that? And then I'll leave it at that, because I don't want to leave us with an incorrect info. So you're mentioning, I think, Tanya, how to make the second step of the proof. Almost, but not quite. What's wrong with what you have written? You or anyone else can say that to me. Well, no, A is there. That's not the problem. Someone else, anybody, please. If you want, just tell us, what is the second step of the proof? It's not a mystery. It's not a guessing game. It's a very precise, exact thing. It's only one thing that it can be. No, it's not A. Good, Jessica. It's assuming A and B, okay? Tanya, do you understand why that is true, that you have to assume A and B? You can't assume A and B, then C, like the first thing you said, because that's the entire statement. Conditional introduction doesn't work that way. With conditional introduction, you just assume the antecedent of the needed conditional. The antecedent is the stuff that's to the left of the arrow, not the thing on the right. So you would have assumed A and B in a second assumption, and then your goal would be to get C. Okay, and there's easy enough steps to get there, but I will leave that for you as you guys continue to work through that problem. Okay? Now, Those are not the hardest of all the problems in the problem set. I think they're actually, to be fair with you, the easiest of all 10. There are some here that are a little trickier. So I want to also reward the people who actually attend the meetings and pay attention. So I'm going to do one of the problems with you. Well, let me actually be a little more careful with that. You're going to do one of the problems, and I'll make sure that it's correct. Okay? So it's group work on problem number 1. All right? We're going to try and do problem number 1, and we're going to solve it together. So I just need a little help from you. Here is homework number 4, problem number 1. And there it is written in the chat or on the screen share, as you can see. Here's the goal. Derive that either C or not A. Okay, make sure that's very legible. C or sharp V there, or not A. And here you have got these two premises. All right. First of all, if A, then both B and not C. Actually, what am I doing here? Sorry. So that's one assumption, and then the other one is that either C or not B. Okay, so there we go. We have a goal to get this. We have these two pieces of info, and then we just can make inferences. So even if it's not like you're 100% confident of every single step along the way, let's just try and make however many inferences we can and just get a little bit further along in this problem. And let's see if we can solve it, okay? So someone please give me an idea of how to start this problem. How can I make progress towards C or not A? Okay, so Jessica, you suggest to assume A for conditional introduction. But no, that won't help. Because suppose that I do assume A for the sake of conditional introduction. Well, what would follow from that? What would follow from that? If I had A, then I could eliminate the conditional on line 1, fair enough, but then I would just have B and not C. But neither of those things is going to help me, because even if I do close the subderivation where I start by assuming A, if it's a conditional introduction assumption, then by closing it, I will produce a conditional, but I don't need a conditional. This is a disjunction. So that's not correct. Let's do another attempt. So Frida and Lily, you've both suggested interesting options. We could take it in either of those two directions. But Lily, since I saw yours first, let's just try that out. Okay, so you say assume A for the sake of negation introduction. Okay. So you want to have a contradiction now. If you can somehow find a contradiction, then that will spit out of the subderivation tilde A. And that would be very good, because tilde A, as you can see, is one of these two disjuncts. So now we've assumed A. Okay, good. By assuming A, we are now able to take further actions and inferences in the proof. So let us consider then what could be the step to do on step 4, based on the fact that now A exists in this proof, together with the other two previous assumptions. So look at the lines, think of the rules, tell me what rule if any, could I apply now, given that there are these 3 statements available. Lily, you say B and tilde C from conditional elimination 1 and 3. Yes, good. Can we all see that? Because I notice, you guys, that sometimes we're leaning a little bit on Lily to give the answer. But you all need to know the answer. And you should be a little bit quicker by giving me a quick response. B and not C. That's conditional elimination 1 and 3. Is this clear? Why is this here? Because line 1 says A, then. And line 3 just says A. That is how conditional elimination works. When you have a conditional, and then you also are later on, or even previously, you have the just antecedent part of it. Those two things combine to eliminate the conditional, and it just spits out the consequent. So there is B and tilde C on line 4. Okay, now we move on to line 5. This is the part of the proof where I figure you're going to have to just try something that maybe you're not 100% yet comfortable with, but there's only really one inference rule that can even be used at this point. Let's see if you have a thought about what that could be. Now we're on line 5. Any inference that you think can help us with this as we continue? There are 11 rules. There's reiteration, and then there is an introduction and an elimination rule for all 5 connectives. Okay, so I want you to just think about what are the main connectives of these different sentences, and then what are rules which pertain to sentences with those types of connectives. So what do you think? Line 5. I need someone with a critical insight to take this next step, because it's perhaps not obvious, at least not immediately. But if you can't come up with it, then I'm not going to tell you what it is. If you can come up with it, though, then I will certainly report to you that it's correct and continue. Okay, so Jessica, you suggest negation elimination. And you, Lily, are saying reiteration of 2. Well, I'm a little confused, though, Lily. Why would you want to reiterate line 2? Why would you want to reiterate line 2? Now, Jessica, good thought about negation elimination. That's going to be coming into play in a moment, yes. But there's something that actually has to happen just prior to the negation elimination rule. And then, Lily, I still have my question for you. What would be the point of reiterating line 2? Because line 2 says C or not B. So I'm just like, 2 and 4 are not contradictions. No, this says and. This says or. They're not the same sentence connective. One is a conjunction and one is a disjunction, so they're not logically contradictory. Conjunction elimination of line 4. Yes, yeah, we can do that. So sure, which of them would you prefer to remove by elimination? You say let's take off negative C or tilde C. Okay. So that's conjunction elimination of 4. Cool. So now we've got tilde C there. Then there's something about line 2. Lily, you mentioned line 2, but it's not just reiteration. We have to do something, sorry to say, a little more complicated with line 2. So that's a big hint for anybody. Looking at what line 2 is, there's a short set of options about what I might be speaking about here. So let's say if anyone can think about that. Let us apply the next inference. What should line 6 do? You say eliminate the negation. Well, Frida, we we already have done negation introduction. And what we're trying to find now is some contradiction in here. We don't quite have it yet. But what we do have is B and tilde C. Tilde C we remove from that conjunction. Now, if we could just get C somehow in here, then that would contradict tilde C, and then we would close this subderivation, give us not A, and then we could just disjoin C to its left. But, good Arlene, this requires that we do disjunction elimination. Not conjunction elimination, disjunction elimination, okay? So, we're assuming C, the first disjunct of this disjunction. Assume for disjunction elimination. Now, the goal of this disjunction elimination assumption is going to be to get the same thing that we would get from tilde B, okay? So, how about this? What's the opposite of tilde C again? What's the opposite of tilde C? That's just a straight question. Okay, it's C. Very good. So if we can get C from both of these two disjuncts, then that will prove that C. And then we will be able to use that as the alternative to this letter, and we'll have a contradiction. So C is the left disjunct. How can we prove C on line 7? This is almost, in a way, deceptively. I mean, it's in a way almost too easy. How can we get C on line 7? Because remember, at this stage of the proof, we have a goal now of establishing C from both of the two disjuncts. Disjunction elimination works by getting a common result from two sides of the disjunction, from both sides. If we can derive C from either side of this disjunction, then we will have succeeded in getting it into the subderivation here, and then that will contradict this letter. But please, don't just listen to me. How can I now prove C? It's very easy. C on line 7, where shall it come from? Not disjunction elimination of 2. We already did that on line 6. But reiteration, very good. The reiteration of line 6. C, reiteration of 6. Okay, good. So the left side is done then. Now, as disjunction elimination continues, you have to assume after the first disjunct, and you get the result you want from it, then you have to assume what next to continue doing disjunction elimination. I'm just asking about how the rule works. You assume one disjunct, you find something from it. And then what is to be done next after that in the order of operation of disjunction elimination? One disjunct of a wedge sentence is assumed, the left one. Prove something from it, in this case, C. Then we do what? I'm just asking you please to remember the rule that you know, which is called disjunction elimination. You assume one disjunct, prove something from it, and then tell me then what's next after that in the proof procedure of disjunction elimination. This doesn't even require you to look at this proof. I'm just asking you a general question. Disjunction elimination, how does it work? One assumes one of the two disjuncts, establishes something from it, and then what is the other part? What's the rest? Disjunction elimination. Please just tell me how the rule goes. Like, to do the rule, you have to know how it works. So you must tell me then, how does disjunction elimination work? Go back in your notes, or your memory, or the book, or some combination of them, and please just tell me, how does disjunction elimination work? A person assumes, I keep repeating myself, a person assumes one of the two disjuncts and then shows that something follows from it. After that, what is the next step of the procedure? This is only half of it. You assume one of the disjuncts shows something, and then what next? Is the chat working? Can somebody type something so that I know you can hear me, or is it broken down? Okay, good, Valeria. Then you assume the other part. Right. So what is the other part of this disjunction? It is tilde B. Very good. Okay, good. Tilde B, assume for disjunction elimination. Don't be confused about that. That's how disjunction elimination works. You have a disjunction, you have to break it down. You have to assume both sides, not just the left. You assume the left, prove something from that, then you assume the right side. Okay, so we assumed the left, C, and then we reiterated C, done. Now we have assumed the right side, tilde B. And now you need to tell me, having assumed the second disjunct, what's the goal? The procedure of disjunction elimination works by getting what result from both disjuncts? If we got C from the left disjunct, what's the goal having assumed the right disjunct? It is to get to what statement? It's okay to struggle with it a little bit, because that is how you learn. But you're struggling now, and good. So continue to just work through your mind and tell me, though, What is the procedure when you assume the second disjunct of disjunction elimination? You have to get to what result then? So you were able to identify correct information that to do disjunction elimination, you have to assume both disjuncts. But there's this last question. What is the result that you try to obtain from the two disjuncts? The needed result, well, good, Jamie, yes, it's C. But in more general terms, in any disjunction elimination, regardless of whether it's this one or another problem, what is the kind of result that you try to get from both disjuncts? Is it the same or different? Let me just say it straightforward. Do you try to get the same result or a different one from both disjuncts when you do disjunction elimination? The same, okay? So what's the same as this? C. So that means that now, as we've opened up this right-hand disjunction elimination assumption, we're trying to get back to C again. Okay, so disjunction elimination works by finding the same result from the left and the right disjunct. We got C from C, which is very easy. Now we need to get C from this tilde beat assumption here. So that's going to take us to the next couple steps of the proof, including step 9. Yeah, let's see if I could just, I'm gonna redraw so that I have a little more room at the top. So let me just remember the order that we did it in. We did negation, introduction, then eliminated this, brought off tilde C. Okay. Then being not C. C or not B. Okay, and so yeah, we did the assumption of A for negation, introduction. That we eliminate the conditional, gives us B and tilde C, 1 and 3. And tilde C was detached by conjunction elimination of 4. Okay, and then we started to do disjunction elimination, C. Assume for disjunction elimination. Reiterate that. And then the left side, the left horn of the disjunct, mission accomplished. Now, the next point is to assume the right-hand disjunct, tilde C. Sorry, tilde B. Assume for disjunction elimination. Okay, so now, there's all this stuff so far. We're on step 9. We've got this tilde B assumption, and remember, our goal is C. Our goal is to get C in there. All right, so what do you think is a way of doing this? We need to have C. So what is the opposite of C? What's the opposite of C? And by the way, it's tilde C, good. I saw you, yeah, so wait, let me go back up to something that I saw here earlier. Is this AGP, well, anyway, is that Karina? Maybe it is, maybe it isn't. But when you say reiterate 7, you actually can't do that right now because 7 is in a closed subderivation. So that's not available for the reiteration. But we can still get C by doing negation elimination. So right now, tilde C is the opposite of C. And we want to produce C again inside of this subderivation. So tell me, what is the rule that can allow me to get to C by assuming its opposite? That rule is called what? We're now thinking of a certain rule which allows you to derive an opposite statement by assuming the reverse of it and then showing a contradiction. So if we're trying to get letter C by means of that rule, I'm just asking you the name of the rule then. Negation introduction. Sorry, no. Negation elimination. Thanks, Jessica. All right, so tilde C we assume here for negation elimination. This tilde C has been assumed for negation elimination. We want to strip this tilde off so that we can get C from both of the two disjuncts. Now, focusing just on this last subderivation in the proof, it's a negation elimination assumption. So let's recall how do we close the negation assumptions. When we have a negation elimination or a negation introduction rule, what is the information that allows us to close the subderivation? When we get what? This is not about finding a common result from two disjuncts. Now we're talking about negation elimination. Perhaps a typo there. Yeah, not to worry. But while we're talking to you there, Kalia, tell me, how do you end a negation assumption? We have to find what inside the subderivation? There's rules on rules. Remember all the rules. How does negation rule work? By getting to what? We're talking about negation elimination. Please, just the rule of negation elimination. What is the rule and how does it work? These cannot just be empty words, but you just say, oh, there's a word. You have to get the opposite. Well, you have to get a contradiction. You have to find two things that are opposites, right? So now we're looking for two things here that are opposites. All right. Look above at what's available and tell me what are two sentences that are already here, two letters here, that are opposite of each other. And then we can simply reiterate them, or by means of some inferences, place them inside of this little subderivation structure. So we just need a pair of opposites, right? One thing and the negation of it. Look on the available lines of the derivation and tell me, where are there two sentences that are opposite of each other? In what lines? Or what are they? Can you say 5 and 6? Yes, true enough. But unfortunately, we can't do anything with line 6 because it's trapped inside of the closed subderivation. So look elsewhere. There's another pair of things that are total opposites instead of 5 and 6. So Jessica, you say 4 and 8. Okay, good. Now, to be fair, line 4 is a conjunction, but one of the parts of it is letter B. And line 8 is negation of B. Okay? So, and then again, Frida, no. Just the same with number 6. 6 and 7, neither one is available. This is a closed subderivation. So this is just locked away and you can't touch it. But you can mess with B on line 4 and tilde B on line 8 because this scope line continues and it has not yet been canceled, so that's still available. So then, if I'm talking to you about B and tilde B, tell me how those can now be placed inside of this subderivation. Step 10. What's step 10? We've said you need a pair of contradictory statements. Jessica, you've correctly noted that on line 4 and line 8, there are the materials to have a contradiction, but they have to occur inside this current subderivation. So please tell me then, line 10, how to take a step towards placing them in that subderivation, the needed contradictory pair. Okay, so Dronred, you say B, conjunction elimination of 4. Good. All right. So line 11. Dronred, you seem to know what kind of steps to take, because if you wanted to bring down B and you're following along in the order of operations, then you will know what is the next step. Tilde B, yes. But the rule, please, Jessica, let's be careful about naming the rule, because you say conjunction elimination, but line 8 is not a conjunction. So there's no conjunction to eliminate from line 8. But if you say the right rule, then we can take a step, yes. I'm a little confused, Jessica. Are you saying negation introduction? I'm just asking about tilde B. John Red, you say tilde B, but we can't just say the sentence without giving the rule that allows us to justify it. So what is the reason that we can say tilde B? Good, Lily. It's reiteration. It's reiteration of line 8. So, are those two things opposites on line 10 and 11? Yes, they are. This says B, this says opposite of B. Okay, so then on line 12, what was the reason that we had these two things there? So that we could close this subderivation. And what is the result of closing? Once you initiate a negation rule, and you eventually find two things that are opposites, that is when you close it. And what is the output that is spit out when you are then going to close it? No, it is not tilde C loveth, because that's what was originally assumed on line 9. Negation elimination is to eliminate the negation sign. So good, it's C. Okay, so there's the letter C. What's the justification over here? Good, it is negation elimination. It is not line 6 through 11. What are the numbers? It's also not 3 through 11 either. It is 9 through 11. Good. The numbering over here. If we're closing this subderivation, the numbering begins where the subderivation begins, and it ends where the scope line ends. 9, 10, 11. This is this current subderivation that we have closed. So we cite that. Now, C from this disjunction easily led us to C just by reiteration. Tilde B, the other right-hand disjunct, it took a few more steps. It took an additional subderivation here. But by means of negation elimination and the above information, we were able to get C also from the right disjunct. So disjunction elimination, the way that it works is if you find a common result from both disjuncts, then you've proven that result. So since C has been obtained from both of the two disjuncts, what have we proven then on line 13 that we can now write? We're just closing the various subderivations out now. And since we reached the same thing, letter C, from both of the two disjuncts above, that shows us what? Good, it proves C from disjunction elimination. And that is, now the citation for disjunction elimination, you cite the line where the disjunction was, so that's 2. Then you cite the 2 dashed series where we make the disjunction elimination assumptions. And so if you follow the proof, you see that there's one from 6 to 7. And then, Lily, as you're saying correctly, the other one is from 8 to 12. Okay, so we proved C. And look here. This is tilde C, right? That's tilde C. So these two things are opposites. We started this whole proof with negation introduction. So now we can finally close this negation introduction assumption. And what would be the result of that on line 14? That's going to break this scope line. And it's going to say what? Got to go back in time a little bit. But we started by assuming A so that we could introduce a tilde to it. And all of these steps were simply to lead us to the point where we have tilde C and a bunch of intermediate steps, also C. C and tilde C, these two things are opposites. They fall inside the scope of the A assumption. So on line 14, we should see it say what? Almost Rachel, but there's one step that's right before that. On line 15, we will have that written, Rachel. But for now, there's something that comes right just before that. Negation introduction. So we introduce a negation to this letter A, correct? Tilde A. And the rule for that is what rule? You say tilde A, yes, but just, you can't just guess the information without the rule. Think of the rule first before you think of the letter, if that's helpful to you. But at any rate, what rule gave us this? Good, it is negation introduction, line 3 through, it's not line 3 through 11 though. What are the numbers, please? It's line 3 through what? 3 through 13. Okay, good. Line 15 then is the end. What is line 15 going to say? And what's the rule that will give us the result that we were looking for here? Last step. So if it's the last step, you already know what it should say and what will it say. And then you'll tell me the rule that produces that last step. We got not A. Look at what we needed to derive and put those two pieces together. Okay, love, it's C or not A. But please, what's the rule that establishes that? It is disjunction introduction, correct. But Arlene, the number you have is wrong. It's disjunction introduction, but disjunction introduction only ever cites one number, a single number. So what is the number that is cited on line 15? C or not A, disjunction introduction, line what? Line 14, correct. Because line 14 just says tilde A. Disjunction introduction works by just adding something to only one line. So what has been added to line 14 is the disjunction to the left of C. So we simply add on to line 14. We introduce this disjunction of C or to line 14, and that's the answer. So this is the answer for problem 1 of the homework problem set. I'm not gonna, if people go to office hours and stuff, which you're always all, of course, invited to do, you've done some work, and I can help guide you through some of the steps of the problems. But I don't want to, of course, just give away all the answers in the various meetings that we have. But from time to time, maybe before the homework problem set is due, no, there's no shorter way, Maya. Definitely not. It's this. I mean, maybe there's a shorter way. I don't want to actually say that out of hand. But in general, there's going to be several steps leading you to the proof. Some of the proofs can be done in an alternative way. Like sometimes there are alternative steps that you can take to reach the same result. Like in this case here, we could have made B the other statement that we were trying to build contradictory pair for in this larger subderivation. But there's basically no way to do this one in a very much shorter format. And in some of the problems, there's more steps than this. It's complex, but it's homework, so it's not like a timed test. You have weeks and weeks, 3 weeks to do it. And all the rules are provided for. You have all these lectures, and you have access to me, and so there will be no problem as long as you work diligently and you seek clarification when it's something that's not making 100% sense to you. But this is actually, this one's medium length. Some of them are longer than this, so don't be intimidated by the length. Embrace it, because yeah, they're long. Some of them are long, but it's homework. The ones that I would give you on the final exam are not going to be as tough as some of the ones that are on the homework, just because in that case, even though you'll have more practice by then, it's a little more of a time pressure situation. So I try to make the ones on the homework a little bit more tough, sophisticated than some of the ones that will be on the final. The final exam on the 16th of December, let me pull up the, syllabus, and you'll see it here. I haven't looked at it in a little while, but I think that's correct. Yeah, so it says there, it is Wednesday, the 16th of December, and it is from 11 a.m. to 12:50 p.m. So in the early morning / afternoon. Okay. Yeah, so in general, there's not too much difficulty with some of the problems. It just depends. Like there are differing levels of difficulty. Some of them only take a few steps. This one's kind of in the middle, and then a couple at the end take a little longer. In general, for hints, right? So like this one, it says derive this big disjunction, and all you have as an assumption is itself a disjunction. You're going to have to do disjunction elimination. I'm just going to tell you on problem 3, and it's going to require several steps because first you're going to have to do disjunction elimination, which will isolate A or C. But then you're going to have to do a further subsequence of disjunction elimination on the 2 individual disjuncts A and C. And then you'll just have to show that by means of every single individual disjunct that you break down, you can reach this big formula. So you'll be able to do that. Now, Jamie, the exam is cumulative from the whole class. Yeah, it's cumulative from the whole class. It is, but there's a lot of there's I think 40% of it or something that is all about just derivations. So more of it is weighted towards the second half of the class. But yeah, to the extent that there's cumulative stuff, I think that you should actually feel good about that because if it was all derivations, it would probably be too difficult for you. So it's like maybe less than half about derivations, and then the remaining stuff is definitions, true-false questions, some translations, and a truth table. You need to know this stuff for the rest of your life, not just for another couple of weeks. I want to pop up on you at 3 in the morning in 15 years and be like, derive this formula, and you'd be able to do it. Because logic is something you need to carry with you forever. It's a precious gift. It's been handed down by our ancestors, and we're going to preserve it and keep it strong for the future. So there's a lot of importance to it to me, and I want you to know about it. So that's all for today, guys. I have my office hours from 1:30 to 2:30, as I always do Monday, Wednesday. So anyone feel free to drop in. If not, I'll be in touch anyways, and I'll be in touch with you guys going forward for the rest of the semester, including during the Thanksgiving holiday break. So, you know, I would advise you don't wait till the very last minute to work on these problems. Some of them are kind of difficult, so you want to give yourself enough time and space to succeed. And I'm willing to help you any way I can, check on your work, give you corrections, etc., as we make progress towards that next date. Other than that, if you've got any questions about any of your previous assignments, as I said in the announcement, I welcome anybody to send me an email, and I'll give you a reply within a day or two at the most. So for now then, guys, thank you so much for helping some of our work. I'll see you back on Wednesday. I'm going to end this meeting, the Zoom, and then I'm going to close the YouTube meeting, okay? So have a great week soon. Bye-bye. All right, guys. See you then. Bye-bye.